With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question states, if neutrons exert only attractive force, why don't we have a nucleus containing neutrons alone? So the question is basically asking us, if neutrons exert only attractive force, they don't exert any repulsive force, and neither they do have any charge, so they are neutral species. Why don't we have a nucleus containing neutrons alone? Why don't we have a nucleus that contains only neutrons and no protons? Let's understand why don't we have it. Okay. So for that, we need to draw an atom. Let's suppose this is our nucleus, right at the center of an atom. And then we have outer orbits, and they're not perfectly circular. They are somewhat different, but let's draw it like this here. So these are our outer orbits. Okay. Now what do we have in these outer orbits? What do we have? We have electrons, right? So for example, this is our electron, and this is our electron, this is our electron, everywhere we have electron in these outer orbits with negative charge. And what do we have in a normal nucleus? We have protons and neutrons. Let's suppose this is our proton and this is our neutron. Okay. Now what happens is that in a stable nucleus, these protons, they attract electrons towards them, that means towards the nucleus, and they don't leave these electrons. They don't let them go, and they are bounded because of these protons towards the nucleus, and the atom is stable. Now suppose we don't have these. We don't have these protons here. We just have neutrons. Neutrons are neutral. They don't have any charge. They have mass, but they don't have any charge. So what would possibly attract these electrons, or say what would possibly stabilize the negative charge of electrons when positive charge is not present? Can it be possible? No. So that means when we have only neutrons, these electrons are free to go anywhere. Earlier, protons, they exerted force, attractive force, and at every point they were bound to this nucleus. No one was allowed to go anywhere. They were bound to this nucleus. Now they don't have anything. No one is exerting force. No one is holding them, and now they can go anywhere. So electrons are free to move. Electrons can be anywhere outside this atom. Now they are no longer an atom. Would there be stability? No. And one more thing is there. This neutron itself is not so stable. We know neutron undergoes beta decay. So because of that decay, we say that if we have only something made up of neutrons, that is a highly radioactive species. When that is radioactive, that means it would undergo decay. Suppose in this case it is beta decay. So we know radioactive species are not stable, but everything in this whole universe it demands stability. So for stability reasons and for the real structure of atom, we cannot have nucleus. We cannot have neutrons alone in the nucleus, because we need to hold these electrons in the atom, and for that we need protons. So that's it. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.